Over the last 50 years, apart from air cap development, the technology behind the air atomizing spray gun has lain somewhat dormant. However, the last few years have seen frantic activity in the research and development departments of the major spray equipment manufacturers, sparked off by legislation invoked in one American state to overcome their environmental problems. Now, their ruling enforced the use of spray equipment with a threshold of 65% transfer efficiency and nominated high-volume, low-pressure guns with a maximum of 10 psi atomizing pressure as one of the approved systems. Other states and countries are now following California's lead, and the control of solvent emission and the use of high-volume, low-pressure or other high-efficiency spray systems will eventually become widespread. High-volume, low-pressure, or HVLP as it's generally referred to, is not a new method of atomization, but is simply, as the name suggests, a change in the proportions in which the air is delivered to the gun. So let's look at one of the latest generations of HVLP guns, the DeVilbiss Duotech JGHV, and we can compare its basic air pressure and volume requirements with its conventional stablemate, the JGA. This diagram shows how a JGA conventional gun with a number 86 air cap and 50 psi at the gun inlet consumes 13.7 cubic feet per minute of air. With HVLP, the JGHV gun with 25 psi at the inlet giving only 10 psi at the air cap, the gun consumes 17 cubic feet per minute. The JGA is recognized as providing the optimum combination of performance, control, comfort and durability. And throughout this video, we'll be using the JGA gun as the control factor against which we can judge the HVLP package and what it has to offer for the professional refinisher. At first glance, the guns are fundamentally very similar. So what are the differences in the way the gun operates and is controlled? Well, due to the higher operating air pressures, the JGA functions as a suction or siphon feed gun, drawing up paint from the cup using the energy from the air movement. In the case of HVLP, the lower atomizing pressure provides insufficient siphoning effect, and the cup needs to be pressure fed to ensure adequate fluid flow is maintained. With the JGHV gun, paint feed to the cup is taken care of by a compact, preset, quick detach regulator at the base of the gun handle. This maintains a constant pressure into the cup regardless of the input pressure to the gun. When the air line to the gun is disconnected, the regulator depressurizes the cup, and although the pressure is very low, this avoids the possibility of spillage when the lid seal is broken. Pressure feed has the advantage that by simply changing the air cap, fluid tip and needle combination, a wide variety of viscosities can be handled, from high-build primer surfaces, which may have previously required the use of a gravity feed gun, right through to low-viscosity clear coats, all fall within the scope of a single gun. For strength without weight penalties, the gun is drop forged in aluminium, and in keeping with its JGA parentage, the gun has excellent fit, feel and balance. A standard integral airflow valve controls triggering air, and the gun has a unique twist-action spreader control ring at the gun head, which acts like a camera focusing ring to give a range of patterns from fan to round. So, having seen the functional differences, how should the gun be set up and used? Well, as the gun is pressure-fed, the first requirement is to fully close the fluid needle adjustment and ensure that the spreader control ring is set to full open or maximum fan. Having removed the working air cap, we now attach the special pressure test air cap and gauge, With this in place, we pull the trigger back to its first stop and then adjust the wall-mounted filter regulator to give us a maximum of 10 psi, 0.7 bar at the air cap. However, before we examine the concept of high-volume, low-pressure atomization in more detail, we should consider the three performance factors, apart from manufacturing quality and comfort, that directly govern the choice of a spray gun. The three factors are, in order of importance, finish quality, application speed, and transfer efficiency. Finish quality is perhaps obvious, but for today's professional refinisher, a gun must be capable of applying a top quality finish with a wide variety of paints, shades, and effects. Close behind in importance comes speed of application, which is, in terms of the gun's specification, the material flow in cc's or litres per minute that the gun can properly atomize. Finally, there is the bonus factor, transfer efficiency, which represents the percentage of material that the gun is capable of depositing on the workpiece. This efficiency factor determines the economy of use, the working environment, and the frequency of booth maintenance. Although it may seem strange, transfer efficiency is the easiest factor to achieve, and the many claims regarding paint savings of 50% and even more are achievable. However, there is always a sacrifice, which is usually a combination of loss of finish quality and a reduction in speed, which renders the equipment unacceptable for the refinisher. Now, keeping those three factors in mind, let's examine how Duotec HVLP scores for each consideration. We've set up the gun, as seen earlier, with the air cap test gauge to 10 psi atomizing pressure, and now we can watch the gun in action. Firstly, on a paper roller machine. For this part of the video, we have a JGA gun with an 86 FW setup. With 19-second viscosity, medium solids straight color paint, this will act as our HVLP performance comparison. Firstly, using the JGA and a handspan gun-to-target distance, we spray out a vertical pattern to check that the air cap and fluid tip are combining to give a uniformly shaped straight pattern without evidence of any dumbbell shape, which would reveal itself as banding when the gun is on the move. Alongside it, we repeat the action with a JGHV, and we can see a very similar, usefully large, straight-sided pattern. Now the operator gives a very rapid spray-out pass onto the paper, and we can see that both the conventional gun and the Duotec gun produce very similar, fine atomization characteristics that will ensure good laydown and gloss. Next, we turn the air caps on both guns through 90 degrees and static spray out horizontally, which, once the paint begins to run, verifies if the guns are uniformly distributing the material throughout the extent of the pattern. This distribution factor is crucial to avoid any evidence of flotation or mottle, particularly when using metallics. Whilst we have the opportunity, we can watch the action and ease of use of the JGHV's spreader control as it changes the pattern shape from full fan down to a round spray. Finally, we spray the paper from top to bottom, triggering the gun well within the width to avoid enforced overspray. Whilst watching the application speed, note the amount of paint on the paper outside of our boundary lines, and the spray fog at the sides of the roller machine as it's pulled away by our water wash side extraction booth. With the JGHV high volume low pressure gun, you'll notice a marked reduction in the amount of costly and troublesome spray fog due to the reduction in forward velocity, which reduces the bounce back and wastage. At the conventional JGA's operating pressure, air which hits the surface bounces back and prevents some of the atomized material in transit from ever reaching its target. The advanced performance of the JGHV 602 gun is the result of many years of research here at the company's Bournemouth headquarters. Now, this laser particle analyzer in the Research and Development Laboratory provides accurate information of a gun's atomization performance from which comparisons can be made. Here, using the analyzer's computer, the frequency and size of particles within the JGHV's spray pattern are compared to test data recorded by a JGA gun. It's known that there is a minimum effective size for a paint particle to be of value in a spray pattern. If it's too small and light, it'll be easily blown away as wastage. So let's return to the booth and see how the Duotec JGHV can adequately match the performance of the conventional gun in both speed and finish. Here we can examine how that reduction of visible spray fog translates into real material saving. This time, under test conditions, we'll apply a medium solids paint to pre-primed vehicle panels. We set both guns to an identical fluid flow by weighing them before and after spraying out for 10 seconds duration and multiplying by 6 to determine 1 minute's flow rate. Now, from extensive testing, we know that the JGHV is approximately 20% more transfer efficient, so we next reduce the JGHV's fluid flow by that amount. With the JGHV set at 10 psi air cap pressure and a target distance of 6 inches, and the JGA gun set at 50 psi gun inlet pressure and at a target distance of 8 inches, our operators spray the panels. They keep to a standard stroke overlap and, as closely as possible, work at the same speed. Having visually established that the finish is satisfactory, using a wet film gauge we find that the thickness of the coating is identical with the JGA and the JGHV, each having applied 76 microns. So we now return to the scales, reweigh both guns and subtract the final weight from our starting figures to establish the volume by weight of the material used by each gun. In this instance, the JGA has used 116 cc's and the JGHV has only used 93 cc's to apply the same film build at the same speed. This confirms that we were right to reduce the JGHV's fluid flow by 20% and that reduction represents the difference in efficiencies between these two guns. This decrease in fluid flow is particularly relevant when panels are being sprayed off the vehicle. To ensure edge coverage, it is of course necessary to spray into space beyond the panel, and here any reduction in the fluid flow will significantly save paint whenever enforced overspraying action is necessary. Conversely, we could have set the JGHV fluid flow at the same rate as the JGA, in which instance the Duotec operator would have needed to work faster so as not to apply a higher film build than necessary. This is a danger with a good HVLP gun, as operators hearing a lower noise level from the reduced atomizing pressure tend to automatically reduce their speed, and slower passes will result in overloading. Let's recap for a moment on this efficiency equation, as it is fundamental to understanding the benefits of high-volume, low-pressure atomization. Accepting that due to a lower pressure and reduced bounce-back fog, the HVLP gun is more transfer efficient, there are 3 ways in which the benefit can be utilized. 2 of these assume the user needs to operate the gun at the same fluid flow rate as he does today with his conventional gun. Firstly, he could apply a higher film build working at the same speed as previously with a conventional gun. Alternatively, if practical, he can use a faster application rate if the same film build is required as obtained with a conventional gun. Finally, and of the greatest interest, as we've seen in our test, is the ability to work at the same application rate and lay down the same film build as with his conventional gun, but he can reduce the fluid flow and save material. With Duotec, all 3 options produce a paint saving of up to 20 to 25%. The way of working is up to the operator. Of course, the tests you've seen were conducted with the gun set at precise pressures and working at correct target distances. Under such conditions, the efficiency of a conventional JGA gun may be seen to be higher than in normal working conditions, and most body shops will notice a higher efficiency differential than demonstrated in this video. For operator convenience, the Duotec JGHV cup gun is available in a basic or a professional carry case refinisher's kit with a choice of 4 air cap combinations, quick detach fittings and an air cap pressure test gauge. For those who prefer gravity feed operation, there is the GFHV gravity gun, offering the same Duotec HVLP performance with a 1-pint nylon gravity cup. Now, looking to the future, we can conclude that despite any misgivings regarding the performance of HVLP guns, it is possible, with the benefit of DeVilbiss Duotec technology, to match the highest quality finishes at fast application rates whilst achieving a 20 to 25% material saving and a significantly improved working environment for the operator.